All right, here we go. Homework for 5-4, putting it all together. Let's see how we do here. Anything to the 0 power is 1. So this answer is simply y cubed. How about that? Moving over to number 2. This is a square root. So I'm looking for two identical factors. I know 40 is 4 and 10. And I know that 4 is a perfect square. So this -2 is joint by a factor of 4. And I know that 10 is stuck inside with no double factors. If I have 7 x's, 3 groups of 2 come out, and 1 is left stuck inside. And if I have y's, those 2 y's come out as 1. When I multiply my coefficients, -8 x cubed y square root of 10x. Alright, when I look at number 3, I've got same base add, so this is 3 times b to the 1/2 plus 4/3 power. When I go to add 1/2 and 4/3, my common denominator is going to be 6ths. So 3/6 plus 8/6 is going to give me 3 times b to the 11/6 power. For number 4, I have a 4th root, so I want to see how many times 162 breaks down. I know that that's 2 and 81. As soon as I see 81, I know that that's 3 to the 4th. So my x and y hang out, my 3 comes out, and my 2 is left inside. My x to the 7th power, I have one set of 4 that comes out and 3 x's that are left. With my y's, 2 sets of 4's come out. When I combine my terms, or my factors, I have 3 as a coefficient, 2 x's, 3 y's, and the 4th root of 2x to the 3rd. Alright, moving on to number 5. H to the 1/4 power, y squared comes down, z cubed stays, h squared stays, and y to the 4th stays. These y's, 2 of them cancel out, and these h's need to be added. 2 in terms of fourths is going to be 8/4, which gives me h to the 9/4 power, y squared, z cubed. Alright, I've got a 4th index, so when I look at 96, and I go ahead and break that down, that sounds like 2 and 48 to me. 48 is 6 and 8. This is 3 and 2. And then, of course, 8 is 4 and 2 and 2 and 2. So you want to go ahead and, before I do this, though, I might divide by 3 to get that out of the denominator. I like that idea better. So I have the 4th root of 3 into 96 goes 32 times. Let's see how my fractions work out. These 3 x's come up here and give me 5 x's in the numerator. These 3 y's come down here and give me 8 y's in the denominator and z. So I'm not going to worry about this factor tree so much since I went ahead and changed my mind and I divided. I know that 32 is 2 to the 5th. So I know that when I go to take my 4th root of my numerator and my 4th root of my denominator, I know that 4 2's are going to come out along with one of those x's. 1 2 is left inside with the extra x and that z. And I know that this simplifies completely to y squared. Alright, when I have 2 to the negative, or 2 to the 7th, and this x is to the negative, first thing I'm going to do is share out this power. 2 to the 7th times x to the negative 4/7 times 7. The 7's cancel out. So my 2 to the 7th is in my numerator, and these x's here are going to come down to the denominator because it's a negative exponent. Alright, so 154 and 11 have to be friendly numbers. So we can go ahead and put this all under one radical and see about 154 a b to the 12th and 11 a to the 7th b to the 5th. So 154 divided by 11, let's go ahead and take a look at that. 154 divided by 11, it's 14. So I'm going to cancel this out, and this is 14. This 1a is going to take away from one of these a's. These 5 b's is going to take away 7 or 5 of those b's. So I'm trying to take the square root of 14 b to the 7th over the square root of a to the 6th. 14 doesn't have any double factors, so he's going to stay underneath the radical sign. 1b will join him, but I can take 3 groups of 2 out along with my 3 groups of 2 a's. Alright, let's see what the back has in store. I have 2 to the 1/3 to the negative 6th power, which is going to give me 2 to the negative 6/3 power, which is going to give me 2 to the negative 2nd power, which of course is 1/4. 12 times negative 6 is negative 72. Z to the 3/2 plus 1/5 power, because I have same base, add. I'll go ahead and put these into common denominators, which means I have 5/10 for my z, and I have 15/10. So I have negative 72 times z to the 15 and 5 is 20. That's not right. Times 2, this is 2. That's better. So I have to the 17/10 power. Almost made a mistake there. Alright, so I have a power of a power. I'm going to share it out. So that becomes x to the 1/5 power when I multiply those fractions, and y to the negative, the 3 and the 6 is 2, 2/11 power. Because this is a negative exponent, it's going to go to the denominator. X to the 1/5 over y to the 2/11 power. Alright, so I'm talking about some radical computation. I need to see if I can get my radicands to match. So I know that 3 times root 8. 8 is 4 and 2. So that's 3 times 2 roots of 2, giving me 6 roots of 2, plus negative 4 roots of 2. 50 is 25 and 2, so that's plus 5 roots of 2. So I can add that along. Now I have all of my radicands matching. Negative 4 plus 6 is positive 2. Positive 2 plus 7, or plus 5, is going to be 7 roots of 2. Alright, so my x here stays. My y squared drops. This x to the 3/4, and this extra y. So this is going to be same base subtract. So when I subtract those powers, I have x to the first minus 3/4 in my numerator, y cubed in my denominator, x to the 1/4, because this is 4 over 4, all over y cubed. Square root of x to the 4th means that I have 4 times 3. Square root of 4 is 2. 2 of my x's come out. Root 3 is left, along with this 2 in the numerator. These 2's cancel out. So I have 1 over root 3x squared. Let's put the x squared out front, because guess what we have to do here? We're going to rationalize our denominator. This gives me a root 3 in the numerator, and these root 3's, square root of 3 times square root of 3 is going to be 3. So that gives me 3x squared in the denominator. Alright, let's bring this negative exponent up to where it belongs. In the numerator, I have x to the 1/2 power plus 4/3 when I move that up. In the denominator, I have y to the 5/4 power, and that's going to be same base add, so plus another 4th. This is going to be 3/6, and this is going to be 8/6, which is going to give me 11/6 for my exponent on x. And for y, I have y to the 3/2 power. This is 6/4, and then I can simplify. Alright, cube root of 128. So, do you have that memorized? It's not a perfect cube, so we'll go ahead and we'll look at 128, and I know that divides into 2 and 64. And I know this divides into 8 and 8, 4 and 4, 4 and 4. And then this is 2, 2, 2, and 2. 2, 4, 6, 8, 9 2's. So that should have worked out. 128, 2 and 64, 8 and 8. I did it again. Boy, this is my most missed. 8 and 2, or 4 and 2, 4 and 2. So there I have 1, 2, 3, 4, 5, 6, 7 2's. That's better. So when I take the cube root of 128, that's like the cube root of 128. I have 7 2's. So let's see. If I'm taking them out, I get 2 groups of 3 with 1 left over, minus 2 times, let's see, 432 breaks down into 2 and 216. Oh, I know this is 6 cubed, so we're going to take out a 6 and leave a cube root of 2. 54 breaks down into 9 and 6. And here's my 3 3s. So 54, see, 5 times 3 comes out, leaving me with a cube root of 2. All right, let's clean this up. So here I have 4 cube roots of 2 minus 12 cube roots of 2 plus 15 cube roots of 2. So positive 4, negative 12, sounds like negative 8. Negative 8, positive 15, sounds like 7 cube roots of 2 as my final answer. Alright, let's take a look at 17. 2 times k, here's my same base add, so 1/3 plus 2, I can write 2 as 6/3, and guess what? These 3 are going to come back up 2, so that's plus another 9/3, because 3 in terms of thirds is 9/3. So that's going to give me 2 times k to the 10/16 thirds. Alright, so 18 and 54 both share a factor of 6, so I can call that the square root of 3r10 over the square root of 9 once I factor that 6 out. So 5 of these r's are going to come out. My square root of 3 is still in, and then I have 3. All right, be prepared for your quiz tomorrow.